reaching tunnel.
Under the ocean, there's a tunnel so ambitious people call it impossible, and it actually works. On screen.
This is the Channel Tunnel, an undersea rail link connecting Britain to mainland Europe.
Keep it moving.
Depending how you count costs, inflation, and financing, it gets described as a $15 billion mega project.
They tried for decades.
The wild part? People dreamed of building this for more than a century before it finally happened.
Now, today we're going inside. How it was built, how it survives the sea, and what's down there.
3 bores.
It's not one tunnel, it's 3. 2 rail tunnels and a smaller service tunnel in the middle.
The service tunnel is the hero, used for maintenance, emergencies, and access to everything.
Service link confirmed.
The undersea portion alone is roughly 38 kilometers. That's the headline under the ocean stretch.
Undersea span.
The undersea portion alone is roughly 38 kilometers. That's the headline under the ocean stretch.
Undersea span.
At its deepest, the tunnel sits tens of meters below the seabed, far below anchors and waves.
Depth verified.
They aimed for a chalky rock layer called chalk marl, which is relatively stable and less permeable.
Chalk marl. Samples clean. Years of surveys mapped the seabed and the rock because one bad zone could mean flooding or collapse.
Motion delayed.
Even with good rock, the project was political chaos, debates, delays, and massive financial risk.
Both crews ready. Then the real race began. Dig from both sides and meet perfectly in the middle.
Cutterhead live!
They used tunnel boring machines, giant steel monsters that chew rock non-stop.
Ring set.
As the machine moved forward, crews lined the tunnel with concrete segments, like building a tube, ring by ring.
Belt steady!
All that crushed rock had to go somewhere, so conveyor systems carried it back out like a factory line.
Stay tight, moving through.
Underground, it's loud, hot, cramped, and dangerous.
Line is true.
Precision mattered. Laser guidance and constant surveying kept the tunnels on course under the sea.
Hold the line!
Imagine digging under an ocean with no GPS down there. Only math, instruments, and nerves.
We've got contact.
When the two sides finally met, the alignment error was time, an iconic engineering bullseye.
Cross passages connect the tunnels at regular intervals, so people can escape from one to another.
Intervals marked.
This way, please.
In an emergency, the goal is simple. Move passengers into the service tunnel, the protected backbone.
Airflow set.
Ventilation is critical. The tunnel controls airflow to manage heat, smoke, and normal train operations.
Keep moving, this way.
Fire is one of the biggest threats underground, so response plans focus on containment and rapid evacuation.
All lines live.
Power, lighting, communications, and monitoring systems run the entire length, like a hidden underground city.
Monitor that alert.
Above ground, control centers track trains, sensors, and alarms because small problems underground escalate fast.
Passenger said clear.
Passenger trains plus vehicle shuttles use the tunnel, so it's not just trains, it's transport logistics.
Straight ahead, slow.
Yep. Cars and trucks drive onto special shuttle trains, then ride through under the sea.
Now the scary question. What stops the ocean from pouring in like a movie disaster?
Pressure holding.
The tunnel lining is sealed segment by segment, with joints designed to resist water seepage and pressure.
Seal looks good.
Any water that does get in is managed. Drainage systems and pumps handle seepage before it becomes a threat.
Flow normal.
Depth matters. Going deeper into solid rock reduces risk from the dynamic forces near the seafloor.
Deeper is steadier.
Checks complete.
And constant inspection is the real secret. This place is maintained like an aircraft. Routine, strict, non-stop. 2 minutes.
Maintenance often happens in tight windows because closing a major international link costs serious money.
All sensors green.
Sensors watch everything: heat, smoke, airflow, equipment status, so operators can react early.
Control, loud, and clear.
Communications are built in, including emergency systems, because underground, confusion is dangerous.
Through here, keep moving. Those cross passages you saw, They're designed for fast movement away from danger, not comfort.
Service route clear.
That's why the service tunnel exists. Separated space, dedicated access, and a safer corridor under the sea.
We did it!
Building it was only half the battle. Then came testing, certification, and proving it could run daily.
Block clear.
Rail tunnels rely on signaling, strict rules, and coordination because there's no room for error at speed.
Feels smooth.
At speed, this feels like any other train ride, which is the whole point. Extreme engineering made invisible.
Above ground, giant terminals handle ticketing, security, and loading, so the underground part stays efficient.
Lane 3, boarding.
Freight matters too. Moving goods quickly across borders is one reason this tunnel is economically powerful.
Seal verified. Roll through.
Copy.
So why did people call it impossible?
Because it demanded perfect geology and perfect alignment.
It was also a financial gamble. Massive private funding, big debt, and high expectations from day one.
That's a lot of leverage.
It has to work.
The ocean looks chaotic, but deep below, conditions are stable if you pick the right layer of rock.
But mistakes underground are unforgiving, so safety design and operations had to be obsessive.
Confirm lockout.
Locked and tagged.
Drill start, go.
Team moving.
Drills, protocols, and upgrades are part of life here because the tunnel isn't a monument, it's a machine.
Look closely and you'll see the tunnel's real story. Thousands of parts, all designed to fail safely.
Primary steady.
Backup ready.
Structural lining is only layer 1. The real complexity is the stacked systems keeping everything controlled.
Lining's just the start.
Systems stacked and tracked.
For passengers, it's just enter, dog tunnel, exit. Underneath, it's a choreographed technical ballet.
That's fast. Train tracked. Systems green.
The tunnel shrank the map, turning a sea crossing into a predictable schedule, day after day.
On time, keep flow steady.
That's it?
Myth, it's a glass tube with sharks outside. Fact, you're deep in rock, not staring at fish. So?
Sharks?
No, solid rock.
The view is concrete, lights, and infrastructure, because the safest undersea tunnel is the one you never notice.
Just normal.
That's the point. Systems are designed with backups and procedures, because underground, resilience is not optional.
Transfer test complete.
Backup held steady?
Next stop, Bay 12.
The service tunnel lets crews reach almost anywhere, fast, like a secret highway running parallel to the trains.
Access cart moving.
This tunnel wasn't built for beauty. It was built for pressure. Water pressure, time pressure, and political pressure.
Pressure stable.
Copy.
Cutter head steady. Ring locked.
From rock-chewing machines to sealed concrete rings, the build was a masterclass in large-scale execution. And once it worked, it rewired movement between two countries, quietly, every single day.
Same train as always.
On schedule. The Channel Tunnel proved the concept, so now the world keeps asking, what undersea link is next?
Bigger is possible.
Run the geology.
Still, it's hard to beat this feeling. Trains flying under an ocean through solid rock like it's normal.
We're under the ocean?
Yep. 3 tunnels, cross passages, ventilation, pumps, control rooms, thousands of details, one seamless trip.
All green. Copy.
If you ever ride it, remember, above you is seawater, around you is rock, and it's all engineered to hold.
That's why people call it impossible. Not because it can't exist, but because it shouldn't feel this easy.
We're already here.
Your pick. Want another insane mega project breakdown? Comment which one, and I'll take you inside the next one.